Good morning, students. I welcome you all for this course, Chloroprene Rubber, under the course Elastomer Technology for your class. Now, chloroprene is also known as polychloroprene or neoprene. It is developed during the 1930s, extremely versatile synthetic rubber, developed as an oil-resistant substitute for natural rubber. There are various good features: good chemical resistance, high resistance to aging and ozone, low risk of glazing, better wear resistant than natural rubber, higher cost than natural rubber. This is the negative side. Now this is the overview. You can see elastomers are generally rigid, usually soft. Now when heated, elastomers do not become plastic. Now elasticity of an elastomer material is defined by the degree of cross-linking, and this linking process is called vulcanization. Chloroprene is the common name for the organic compound 2-chlorobuta-1,3-diene. One of the oldest type of synthetic rubber is chloroprene. It is homopolymer of chloroprene produced by radical emulsion polymerization of 2-chlorobutadiene-1,3, or it is also called 2-chloro-1,3-butadiene. Chlorine in the polymer reduces the reactivity to many oxidizing agents. Now, in the case of polymerization, potassium or ammonium peroxide disulfide is the most frequently used initiator. There is sulfur or mercaptan are used for regulating the molecular weights. Sulfur is behaving as the monomer, and it creates sulfur bridges in the polymer chains with 2,6-sulfur atoms, which improve their flexibility but reduce their temperature resistance. WCr doesn't contain sulfur bridges, but their macromolecules can be terminated with the rest of the transfer agent molecule. You can see the structures of WCr and GCr. This is GCr, this is the WCr. Now these are the structural units of chloroprene rubber, right? You have seen in different other polymer synthetic rubbers when we have discussed. You can have the trans and cis trans structures. This is the trans structure shown. The opposite will be the cis structure, and this is the 1,2-chloroprene. Now general properties are neoprene rubber or polychloroprene or CR has good edging characteristics in ozone and weather environment, good edging for weather along with abrasion and flex cracking resistance. Neoprene has limited resistance to deterioration from exposure to petroleum-based lubricants and oxygen. Most elastomers are either resistant to deterioration from exposure to petroleum-based lubricants or to oxygen. Now CR or chloroprene also offers resistance to refrigerants, ammonia, silicon oils, water, ozone, vegetable oils and alcohols. So there are various properties combined with a wide temperature range and moderate cost accounts for the desirability in many seal applications, but not effective in many aromatic oils and offers only limited resistance to mineral oils. Presence of the chlorine atoms in each of a structural unit has influence on its basic CR properties. Now there are different properties are mentioned over here which are improved due to the presence of the chlorine atoms. They are highly polar, they have very low flammability, they can eliminate its cell at higher temperature, so undergo the cell vulcanization. Thus, metallic oxides are added to them because of these effects as acceptors. They have worse dielectric properties than non-polar rubbers. Polar substituents in their structural units definitely increase their resistance to oxidation and ozonization. Now, we'll take a pause after this slide and go to the reflection slide. This is a reflection spot. You are currently watching a recorded video. Now write down these answers. What are the advantages of CR over other rubbers, and what could be the probable areas of application? move to the further slides. These are various application part. Is usually primarily used for gasket, cable jackets, tubing, seal O-rings, tire sidewalls, gasoline hoses, etc. Also used as base resin in adhesives, electrical insulation and coatings. Many useful properties and a reasonable price. Typical working temperature is -35 degrees Celsius to +100 degrees Celsius. These are various applications. Some of the applications rather I have shown. These are the advantages. So the comparison with various different properties of various with different rubbers. This I'll share the PDF file with you. These are the references.